Hey students, welcome back to Ch14 Online. This is the 9th episode of chapter number 14, Statistics Standard 10. In earlier episodes, we discussed about how to find mean, median and mode. In the last episode, we discussed about how to find less than type and more than type cumulative frequency distribution. We also discussed about how to get the ogive curve. Now in this episode, we will understand a very important formula, which is the empirical relationship between all the three measures of central tendency. That is the relationship between mean, median and mode. So let us see what this formula is. 3 multiplied by median equals to mode plus 2 multiplied by mean. This is the equation which is called the empirical relationship between all the three measures of central tendency. From this equation, we will get other forms of the same equation, and we will understand how to get one of these values when the two of these values are given, or some relation between two of them is given and we have to find the third measure of central tendency. So let us solve some of the sums based on this equation. So here is the equation for the empirical relationship between the three measures of central tendency. It is 3 into median equals to mode plus 2 into mean. We can write this equation in symbolical form. We know the symbol of median is m. So we can write 3m equals to the symbol of mode is z plus 2 into the symbol of mean is x bar. So we can also write 3m equals to z plus 2x bar. This is the one and same. Now the same equation can be written in some different forms. Let us see how we can write it. Here if I want to make the equation of mode, I can get mode equals to, I send this 2 mean on the other side, it will become negative. So I can write mode equals to 3 median minus 2 mean. So sending this 2 into mean on the other side, it will become negative. So 3 median minus 2 mean equals to mode. So we can write mode, that is z equals to 3m minus 2x bar. So this is the other form of the same equation. Now one more form we can obtain, that is we can write mode equals to, this 3 median can be written as median plus 2 median. 3 median is equal to 1 median plus 2 median minus 2 mean as it is. Now if we send this median on the other side, we will get mode minus median equals to, here 2 median minus 2 mean, we can take out 2 common, so we can get 2 into median minus mean. So this is one more form of the same equation. We can write it in the symbolical form, that is mode is z minus median is m equals to 2 into median m minus mean x bar. So these are different forms of the same relationship. You have to remember one of these. It will be easy for you to remember either first or second. So you can remember 3 median equals to mode plus 2 into mean, or mode equals to 3 median minus 2 mean, or 3m equals to z plus 2x bar, or z equals to 3m minus 2x bar. So this is the empirical relation which we understood. Now to understand it more, we will take some calculative questions in which we will obtain the values of different terms. Though in your textbook there is no any question given for this method, so we will take some of the questions from some other reference books and we will see how to solve them. Let us see. Now let us take some of the questions based on this relationship. The question is, for some given data z equals to 25, x bar equals to 25, we have to find m, that is median. Let us see, we will use the first equation, that is 3 into median equals to mode plus 2 into mean. we will apply the values which are given here. So we can get 3 into median equals to Z is 25 plus 2 into X bar is also 25. Here 25 plus 2 into 25 is 50. 25 plus 50 is 75. So we get 3 into median equals to 75. We want median, therefore m equals to 75 divided by 3. Therefore m equals to 25. So in this case we will get m equals to 25. This is the answer of this question. So this is the way we can get one of the measures of central tendency when the other two are given. Let us take one more question. Here m equals to 15, x bar equals to 10, and we have to find z, that is mode. To find mode, we can have one form of this equation, that is z equals to 3m minus 2x bar. If we apply the values of m and x bar, 3 into m is 15 minus 2 into x bar is 10. 3 into 15 is 45 minus 2 into 10 is 20. 45 minus 20, it is 25. So here z, that is mode, equals to 25. The next question is, in a given data z equals to 20, m equals to 30, and we have to find x bar. Again we will take the formula z equals to 3m minus 2x bar. Let us apply the values. Z is 20 equals to 3 into m is 30 minus 2 into x bar. So 20 equals to 3 into 30 is 90 minus 2x bar. We want x bar, so we will send this negative 2x bar on the other side. It will become positive. So 2x bar equals to 90. Send this 20 on the other side, it will become negative. So 90 minus 20. Therefore 2x bar equals to 90 minus 20 is 70. Therefore x bar equals to 70 divided by 2, it is 35. So here we got x bar equals to 35. Now the next question is question number 4. In this question the data is given that if x bar minus z equals to 3 and x bar plus z equals to 45, we have to find m. To solve this we can write x bar minus z equals to 3 and x bar plus z equals to 45. If we add both of these equations, we can see here both the x bar terms are positive. So x bar plus x bar will be 2x bar. Here both the z terms are opposite signs, that is negative z and positive z. They can be cancelled out, or we can say this is elimination of z. One positive, one negative z, it is called elimination of z. So 2x bar equals to 45 plus 3 is 48. Therefore we can get x bar equals to 48 divided by 2. So x bar equals to 24. So this way we got x bar 24. This is one of the values, but we want m. Now here we have relation between x bar and z. We can use one of these relations. Let us use x bar plus z equals to 45. In this equation we can apply the value of x bar. So we can write 24 plus z equals to 45. Therefore z equals to 45 minus 24. Therefore we get z equals to 21. So this is other value, that is z. But again we want m. We got x bar, we got z. Now from this we can get m. We have the formula 3 into median equals to mode, that is z, plus 2 into x bar. Let us apply the values. So 3m equals to z, which we have got 21, plus 2 into x bar is 24. Let us calculate this. So we get 3m equals to 21 plus 24 into 2, 48. So here 3m equals to 69. Therefore m equals to 69 divided by 3. Therefore we get m equals to 23. So this way we can get median. Now let's see the next question. Here x bar equals to 21.44 given, z equals to 19.13 it is given, and we have to find m. Again we will use the formula 3m equals to z plus 2x bar. Applying the values, z is 19.13 plus 2 into x bar is 21.44. This is 3m. Therefore 3m equals to 19.13 plus 2 multiplied by 21.44, it is 42.88. So we get 3m equals to addition of both of this 19.13 plus 42.88. If you add them, you will get 62.01. So we get m equals to 62.01 divided by 3. Divide this, you will get the answer. It is 20.67. So this is the value of median in this given data. Now the next question is, in the given data z minus m equals to 2.5. The mean of this data is given, it is 20, and we have to find mode of this data. Now here, as z minus m is given, we know the equation z equals to 3m minus 2x bar. Here x bar is given 20. Z minus m. To get this z minus m term, we can do one thing here. Z equals to, this 3m can be written as m plus 2m. 3m equals to 1m plus 2m minus 2x bar as it is. Now if we send this m on the other side, we will get z minus m equals to 2m minus 2x bar. We send this m on the other side because we have already z minus m value. So we can apply this value directly here. So we will apply the value of z minus m equals to 2.5 equals to 2m minus 2 into x bar, that is mean, equals to 20. Therefore 2.5 equals to 2m minus 2 into 20 is 40. Therefore if we send this minus 40 on the other side, it will be 2.5 plus 40 equals to 2m. Therefore 2.5 plus 40, it will be 42.5. This is 2m. From this we can get value of m. So m equals to 42.5 divided by 2, that is m equals to 21.25. This is the value of m. But we want value of z. So as we have the relation here, z minus m equals to 2.5. In this equation we will apply the value of m. So z minus 21.25 equals to 2.5. Therefore z equals to, this negative 21.25 will go on the other side, it will become positive. So 2.5 plus 21.25. This 2.5 can be written as 2.50 plus 21.25. If you add both of this, you will get 23.75. So we get value of z equals to 23.75. This is the way we can get value of z in this given data. Then we will take one more question, question number 7. The data is z minus m equals to minus 4, and the value of mean is given, x bar equals to 32, and we have to get mode z. Let us first of all take z minus m equals to minus 4. From that we can obtain the value of m. If I send this negative m on the other side, it will become positive, and this negative 4 on the other side, it will become positive. So z, this negative 4 will become plus, z plus 4 equals to m, or we can write m equals to z plus 4. This is the equation of m. Now as we want z, we know the relation 3m equals to z plus 2x bar. In this we will apply m equals to z plus 4, so that 3 into, at the place of m, z plus 4 equals to z as it is plus 2 into x bar is given, it is 32. Therefore we will multiply this 3 with z and 4. Therefore 3 into z is 3z plus 3 into 4 is 12 equals to z plus 32 into 2 is 64. Therefore 3z, if we send this z on the other side, it will become negative. 3z minus z equals to 64. This 12 will go on the other side and will become negative. So 3z minus z equals to 2z. 64 minus 12 equals to 52. Therefore we get z equals to 52 divided by 2. Therefore z equals to 26. So this is the way we can get z in this sum. Now let us take one more question. In the given data, m plus x bar equals to 22 and m minus x bar equals to 2. We have to find the value of z. As here we have m plus x bar equals to 22 and m minus x bar equals to 2. We can eliminate here x, as there is one positive x and the other negative x. So positive negative x can be eliminated. M plus m equals to 2m. 22 plus 2 is 24. Therefore we got 2m equals to 24. Therefore m equals to 24 divided by 2. So m equals to 12. This is the value of m. We want z. Here we have a relation between m and x bar. So we can write m plus x bar equals to 22. In this relation we can apply the value of m. Therefore 12 plus x bar equals to 22. So we get x bar equals to 22 minus 12. Therefore x bar equals to 10. This is the value of x bar. Now as we want z, we can use the equation z equals to 3m minus 2x bar. Applying the values, we get 3 into m is 12 minus 2 into x bar is 10. 12 into 3, 36 minus 2 into 10 is 20. Therefore 36 minus 20 is 16. This is the value of z. So this way we can get the value of z mode. So this was the empirical relationship between all the three measures of central tendency and the sum based on this equation. So this is the end of this chapter. In all the 9 episodes, step by step we have understood different methods. We have understood how to find mean by different methods, how to find mode and median. Then we understood about less than type and more than type frequency distribution curves, that is ogive curves. And finally in this episode we understood about the empirical relationship between all the 3 measures of central tendency. So that's all for this chapter. I'm sure you are getting all these terms, all these methods perfectly. Practice well so that it will be very much useful for you in your examinations. This chapter is really very much easy chapter. So my dear students, if you really like the videos, like them and share it with your friends. Practice more. In the next episode we will meet with some other chapter from maths. Till then, practice well, do well, and finally I would say keep studying online with Ch14 Education Online.